In 1977, humanity launched two machines into the dark, and they never really came back. They kept going past the worlds we thought we understood, past the rings we thought were simple, past the moons we thought were dead. And with every new image they sent home, the solar system became stranger, wilder, and far more alive than anyone had imagined. Voyager 1 and Voyager 2 were not just spacecraft. They were our eyes drifting deeper into the unknown, showing us giant storms, erupting moons, hidden rings, shattered ice worlds, and the pale fragility of Earth itself. What makes their story so haunting is this. The Voyagers did not just photograph planets. They changed the meaning of those planets. Jupiter stopped being a distant striped sphere and became a world of violence and motion. Saturn's rings stopped looking smooth and became intricate, broken, alive with detail. Uranus turned into a tilted mystery. Neptune became a storm machine at the edge of sunlight. And somewhere along the way, the probes turned around and showed us something even more unsettling than any alien world. They showed us home. The Voyager story begins with a cosmic opportunity so rare it almost sounds fictional. In the late 1970s, Jupiter, Saturn, Uranus, and Neptune lined up in a way that happens only about once every 176 years, creating the possibility for one mission to visit all four giant planets by using gravity assists like stepping stones through the outer solar system. NASA saw the chance and refused to let it slip away. So, Voyager 2 launched first on August 20th, 1977, and Voyager 1 followed on September 5th, taking a faster path that would eventually let it overtake its twin. Together, they were sent outward not just as probes, but as pioneers, carrying humanity's curiosity into a region no one had ever explored in detail. Even their earliest images had something eerie about them. Just days after launch, Voyager 1 looked back and captured Earth and the Moon from millions of kilometers away. A quiet reminder that the entire journey began with one fragile blue world fading into the distance. That image now feels almost prophetic because before Voyager, the outer solar system was still full of educated guesses. We had models, telescopes, expectations, but we did not yet have intimacy. We did not yet know what these distant worlds really looked like up close, how their atmospheres churned, how their moons cracked, erupted, or glowed in the dark. Voyager was about to change all of that. When Voyager 1 finally reached Jupiter in March 1979, followed by Voyager 2 a few months later, the solar system opened like a door. Jupiter had been seen before, of course, but never like this. Suddenly, the gas giant was no longer a distant disk in a telescope. It was a living atmosphere of towering turbulence, swirling plumes, violent bands, and storms within storms. The famous Great Red Spot was confirmed as a rotating system of immense scale. But that was only part of the surprise. The atmosphere around it was far more dynamic than scientists had expected, filled with motion and instability that made Jupiter feel less like a planet and more like a giant unfinished engine. But Jupiter's greatest shock may not have been Jupiter itself. It was Io. Before Voyager, many assumed its surface would resemble our moon, old and cratered, scarred, but quiet. Instead, Voyager found active volcanism, real eruptions, plumes blasting material hundreds of kilometers into space, lava lakes, and surfaces so geologically alive, they forced scientists to completely rewrite their assumptions. It was the first time active volcanoes had ever been seen on another world. And then there was Europa, marked with strange fractures across its icy surface, already hinting at the possibility of an ocean hidden underneath. In one planetary system alone, Voyager showed us a volcanic Hell's Cape and an icy moon that might conceal water beneath its frozen shell. That was the moment the outer solar system stopped looking dead. After Jupiter came Saturn, and this was where beauty became something more unsettling. From Earth, Saturn had always looked elegant, almost serene, the planet of rings and symmetry. But when Voyager arrived, that elegance shattered into complexity. The rings were not just a few broad bands, as many had imagined. They were made of hundreds of thin ringlets, tangled structures, kinks, gaps, and delicate features far more intricate than anyone had expected. Voyager also revealed new rings, shepherd moons holding narrow bands in place, and ghostly spoke-like patterns across the B, rings that did not fit comfortably into existing gravitational theories. Saturn's rings went from iconic to deeply mysterious in a matter of images. And then Saturn's moons began telling their own stories. Titan emerged as a world with a thick nitrogen-rich atmosphere unlike anything else known beyond Earth, instantly becoming one of the most compelling objects in the solar system. Enceladus hinted at activity, too, with signs that would later connect to erupting plumes and internal dynamism. Voyager was no longer just cataloging worlds. It was exposing them as places with weather, chemistry, hidden oceans, and active geology. Saturn, the planet that once looked like the most graceful object in the solar system, became a reminder that the deeper you looked, the stranger things got. After Saturn, Voyager 1 was flung upward out of the plane of the solar system and began its path toward interstellar space, leaving Voyager 2 to continue the grand tour alone. That journey took it to Uranus in 1986, a world so unusual it still feels almost unreal. At first glance, Uranus looked calm, almost blank, with a smooth atmosphere lacking the dramatic visible features seen on Jupiter or Saturn. But beneath that quiet face lay a planet tilted on its side, with a magnetic field wildly misaligned from its rotational axis. Its magnetosphere wobbled in ways scientists had never seen before, forcing them to rethink how planetary magnetic fields work. Voyager also found new rings, new moons, and a collection of icy worlds scarred by canyons, tectonic fractures, and bizarre geological histories, especially Miranda, which looked like a broken moon stitched back together. Then came Neptune in 1989, the final great planetary encounter. And at the edge of the known solar system, Voyager 2 found not stillness, but violence. Neptune's winds were ferocious, reaching extraordinary speeds, and the planet hosted the Great Dark Spot, a massive storm system rotating through its atmosphere like a shadow in the blue. Its rings turned out to be incomplete and dusty with strange arcs that raised new questions about stability and formation. And Triton, Neptune's largest moon, offered one final shock. A frozen landscape with fractured terrain, geyser-like plumes, and signs of active processes on one of the coldest worlds ever seen. By the time Voyager 2 left Neptune behind, it had finished the grand tour, but it had also delivered a much bigger message. The outer solar system was not quiet, simple, or frozen in time. It was restless, diverse, and full of worlds that refused to behave the way we expected. One of the most powerful things Voyager did was force humanity to stop thinking of moons as leftovers. Before the mission, many of them were treated almost like decorative companions to the giant planets. Smaller worlds that might be interesting but not transformative. Voyager destroyed that idea. Again and again, the probes revealed moons that felt like full worlds in their own right. Places with geology, weather, chemistry, and deep internal histories written across their surfaces. What had once seemed secondary suddenly became some of the most compelling terrain in the solar system. That shift matters because it changed the emotional map of space exploration. Io was erupting. Europa looked cracked open by hidden forces beneath its ice. Titan vanished behind a dense atmosphere that hinted at something complex below. Miranda looked shattered and rebuilt. Triton seemed frozen and yet strangely active, sending dark plumes upward from one of the coldest regions ever visited. Voyager made one thing unmistakably clear. The solar system was not made of planets with a few silent satellites hanging around them. It was made of systems within systems, entire families of worlds, each carrying secrets large enough to deserve missions of their own. After all the storms, all the rings, all the volcanic worlds and shattered moons, Voyager gave us one of the most haunting images in the history of science by looking back. Far from the giant planets, far from the warm illusion that Earth is somehow central, one of the probes turned its camera toward home. What it captured was almost unbearable in its simplicity. A tiny point of light suspended in a sunbeam, fragile and nearly lost inside the immensity around it. That image would become known as the pale blue. And that image changed the journey just as much as Jupiter or Saturn did. Because suddenly the mission was not only about discovering what is out there. It was about understanding what we are in comparison to it. Every empire, every war, every dream, every life ever lived. All of it on a dot so small it could disappear if you blinked. Voyager had crossed the solar system and found storms the size of planets, moons with volcanoes, rings finer than anything expected, and magnetic fields stranger than theory allowed. Then, in one quiet glance backward, it showed us that home itself was almost impossibly delicate. That may be the most mysterious image of all. Most missions are remembered for where they stop. Voyager is remembered because it refused to stop. After the great planetary encounters were over, both probes continued outward into a region no spacecraft had ever truly explored before. The planets were behind them, but the mystery only deepened. The sun's influence began to thin. The solar wind weakened. The environment became stranger and quieter, as if the probes were sailing toward the edge of a vast, invisible ocean. And then came the crossings that made history. Humanity's first entry into interstellar space. That part of the story feels almost mythic. Two machines built in the 1970s, still alive decades later, still sending signals home from the threshold between our solar system and the galaxy beyond. They were no longer just planetary scouts. They became boundary markers, the first physical object from Earth to pass into the space between the stars. And there is something deeply eerie about that, because even after everything they had shown us, the Voyagers kept going into a darkness no camera would ever fully illuminate, carrying with them the final whispers of a civilization that sent them out before many of the people watching today were even born. As extraordinary as the images were, there is one detail that makes the Voyager journey feel even more emotional. Each probe carried a golden record, a message from Earth intended not for scientists, but for the unknown. Sounds of nature, human voices, music from different cultures, greetings in dozens of languages. Not because anyone knew it would ever be found, but because the act of sending it mattered. Voyager was not just a machine. It was a time capsule, a drifting archive of what humanity sounded like when it still stood at the edge of the solar system and looked outward with hope. That is what gives the mission its haunting beauty. The probes were built for science, but they became something larger. They became messengers. They carried our curiosity past Jupiter, Saturn, Uranus, and Neptune, and then kept going long after their primary mission was complete. And somewhere out there, beyond the planets, beyond the heliosphere, beyond the familiar warmth of the sun, they're still traveling with a portrait of Earth attached to their sides. It is one of the most beautiful ideas humanity ever launched. That while we were learning how small we are, we still chose to leave behind a record saying in effect we were here. In the end, the Voyager probes did not just travel across the solar system. They transformed it. Before Voyager, the outer planets were distant names, blurred lights and telescopes, places defined more by theory than intimacy. After Voyager, they became worlds. Jupiter became a realm of endless storms and volcanic moons. Saturn became a labyrinth of rings and hidden complexity. Uranus became a tilted enigma with broken-looking moons and a magnetic field that defied expectations. Neptune became a blue giant of violent winds. And Triton became one of the strangest frozen worlds ever seen. The solar system went from familiar to shocking because Voyager showed us that distance had been hiding not emptiness but detail. But maybe the most powerful part of the journey was not what the probes revealed about those worlds. It was what they revealed about us. After crossing the domain of the giant planets, after photographing storms, rings, ice, fire, and darkness, Voyager turned back and showed Earth as a tiny point of light suspended in the vast black. That was the moment the mission became more than exploration. It became perspective. The Voyagers taught us that the universe is enormous, beautiful, violent, and indifferent, and that our home is fragile beyond words. And still the story did not end there, because the probes kept going beyond the planets, beyond the sun's protective bubble, into interstellar space, carrying with them the last fading signals of human engineering and the golden record. Our small attempt to introduce ourselves to a universe we barely understand. That is why this journey still matters. Not only because Voyager showed us what is out there, but because it proved that a civilization from one small world could build something that crosses the dark and keeps speaking. So maybe the real legacy of Voyager is not just scientific. Maybe it is this. The moment humanity stopped looking at the solar system as a map and started seeing it as a living, mysterious place filled with worlds, histories, and unanswered questions. If you enjoyed this video, leave your favorite Voyager moment in the comments below. Was it Jupiter's storms, Saturn's rings, the mystery of Triton, or the pale blue? And subscribe, because if the Voyager probes taught us anything, it is that the farther we travel into the dark, the stranger and more beautiful the universe becomes.